Hi, I think this video is not going to be as long as the last one. In fact, I'm sure it won't be. The last one was like 2 hours. In this one, it's only two feature-like things that I've added. And load testing was something that someone in the comments for the previous video asked about. So I wanted to add that. And as I was thinking about load testing, it led me to think about locking. Basically, what happens if two users are making changes to a record at the same time? And I thought, oh, yeah, I didn't really account for that, did I? And that led me to add a version column for the users and the products, and then to employ that as part of what is commonly called optimistic locking. There are other strategies to deal with conflicts, and you can look those up on your own, but I thought this strategy, just looking at the version, would be sufficient for this kind of application. So I'll talk about that, and then I will go on to the load testing that I added to the GitHub workflow. Let's take a look at some of the code that's relevant to catching conflicts. So here I'm looking at the products route. The changes in the users would be analogous, to be about the same. So we already had validation errors, but now I've added the requirement that there's a version provided. So when and this is only relevant to put and patch, right? So to make sure that there's a version provided, get the current product, so the one that the user has been working on, and it's not found, then we throw an error. We take a look at the version. So this is the version that's provided in that's passed into this put, right? So we get the value from the request body, get the version from that, and if it doesn't match the current product version, which is to say the version that is in the database that we just immediately got right now, as we entered this function, then we throw a conflict error. We say product has been updated by another request. Please reload the page and try again. So obviously this isn't optimal for all situations, and you could have more sophisticated ways of reconciling two or more different changes going on. I don't know. Imagine some website, some store website or an airline website or something where there's multiple changes going on, and there could be multiple people changing a record, and they're not necessarily they could be changing different things, right? They could be changing things that are not relevant to each other, and so you could reconcile those and kind of merge those changes. But in this case, like in the simplest possible case, you can just say, okay, well, something has changed, someone else has changed this record, so you're gonna have to start again. And that's that's a kind of I don't know, I guess a business decision about what's acceptable for a given type of application. So we return this conflict error, and here I've just made a custom error class where here conflict error, and just giving it a number and a name and all that business. And throw that, right? And then we store the version. I mean, here we make doubly sure that that we only update where the ID and the version match. Here we have another chance to catch a conflict, right? So being very, very careful. And then if we look on the front end side, let's see if I can find it. Products, components, product update. Handle form submit. So I changed this. I think I just had a console error before, and here I've added the Angular Materials snack bar. So it's going to pass in that error message from the back end about the conflict error. Yeah, so I think I did at the snack bar there too. And again, the changes are analogous for the user's type. So let's take a look at the integration testing. So put should return a 409 conflict when there is a version mismatch. So here we're creating a product. We go ahead and create that product, and its version is going to be 1. Then we start to update or create an object to update it. And we use put to put that in and get the first response. And that response should have a version of 2. And here we create a second update, but we're going to use the version from the first one. So this is going to be a 1. And when we do the second put, it's going to try to put version 1, make a version 1 change, but it's already got a 2 in the version column. So the response should be 409. Conflict product has been updated by another request. And here's a similar test for patch. For the patch operation, I actually don't use the patch in the front-end application, but this API provides it. So same kind of test there. Let's see what else I changed. This is all related to the conflict error or the conflict handling. These are the product and user integration tests. I have a unit test for my conflict error. I added this, which I showed. The error handler, I added instance of conflict error. Now it's getting long, so we could probably refactor that and use something else, some other structure. This is kind of what I showed already, although let's take a look at product schema, because I made some changes to that. And I updated this. There were some fields some other columns that I had added previously that I hadn't updated in this schema. So they are there now. You see the version is here. Yeah. All the patch schema, user schema. Okay. What else? Hang on. What else? I also made changes to the shared library or the shared NPM package that I created that is used by the front end and back end. So if I look here, see that I added the newer whatchamacallit, columns. Have those other fields in there. Those are all in there. Yeah, as I was mentioning before, snack bar, I added that in to give a pretty error display. Anything else? These are the front end updates to the front end tests so that they would check for the display of the snack bar. Again, as always, the link to the repo is in the description of the video, so you can look in detail at this if you want. Oh yeah, well, just to wrap things up, let's see what else I added. Migrations to create the version columns, add version to users table. Right, so it's going to be an integer, defaults to 1, and then I also added updated at and created at because I forgot or didn't think of using them before, but now you can see that they're here and there are triggers to set those values. So you get the date set when something is created or replaced. You get the updated you get the data in the updated at column. Anything else? Wait a second. 1 second. Okay, where was I? I got distracted. The created at and the updated at default to now, so that's how they get their values. So same for users and products. What's next? Go back to this. Oh, hang on a second. That is too small. Oh, too big? No, that's okay. What else? Yeah, here I just added a way to invoke just the user's integration test and just the products test. What I'm doing there, or the reason I'm doing that is to I don't want any conflicts with the database when I'm doing the migrations and seeding. Yeah. So here's the seeds for the product. I just added version to that. Okay, I think that's all for the first thing I was going to talk about, which is the optimistic locking. Now let's take a look at load testing. And for here, I added a new section to a new block. I'm not sure what this kind of thing is called, to the workflow. So in addition to test and deploy, I have a load test, and I put the load test after the deploy, and depends on deploy because I want to test to make sure that that I'm testing against the new deployment. And I added this step to the deploy section. So we wait for the ECS services to be stable. In this case, it's only the backend that's relevant, so that's why I give it the backend service name. And then we have this block here, load test, and we can run load tests with this action that's provided by GitHub. I'm not sure if they created or if you just access it via GitHub, but anyway, you can invoke it like that or use it like that. And then the file that I'm using is this one, load test.js, and as an environment variable, I give it a base URL, this one, which we know from the previous video. So then let's look at this load test file, which is relatively simple. Is that legible? Maybe it's more legible if I look here. Let's see if I find it here. All right, so there's the test, load-test.js. And there are different kinds of load testing tests. And you could do a smoke test to verify that a system can not handle, but handle a minimal load without issues. You could do a stress test to find a breaking point. VU stands for virtual user increase. God, look at all these typos. I thought AI was supposed to catch that. By increasing the number of VUs until the API starts returning errors or response times degrade significantly. You can do a spike test how the system handles sudden spikes in load. You can do a soak or endurance test the system's stability and performance over an extended period. You can do that. So just for the sake of demonstration, I did pretty simple load tests. So just imagining a kind of peak load condition. Obviously, my site is not really a real site, not an actual live public site. But you can imagine. You can use your imagination and think, well, the target number of users could be a million, could be 100, who knows? And then you can put in values for how long. You're gonna have to come up with your own scenarios. And then it runs those tests. That's the whole thing. This thing right here. And I can show you how this and all the tests run. I think that would be the relevant thing to do. Hang on one second. So we can kick off some tests by saving some changes in this pull request. They're just little cleanups. Nothing really that interesting. I mean, what do I want to say? What I want to say is nothing significant. I just made change it, remove comments and console logs and things like that. So I don't really care about the commit message. I don't think I have to set an upstream thing. Let's do that. Then let's switch over to GitHub. So we've got this pull request. Let us get to pull request. And that's going to kick off some testing. And most of this you don't need to see, so I'm going to pause the video until we get to the load testing part. Still with me? Here's the deploy stuff going on. I'll check back in a moment. This probably, let's see, how long is this going to take? Shouldn't take long. Hang on a second. Okay, so let's check back in. We were waiting for the ECS backend service update. That took 2 minutes 48 seconds, so a little bit of a wait. Now let's switch over here, and we've got the load test going on. And that's going to continue for a while because that's what it's supposed to do. Where are you? Oh, not there. Because that's what it's supposed to do. So this is what we are supposed to do, the different stages. 1 minute, 3 minute, 1 minute. Let's look back over here. And this will just keep cranking away, and I'll pause the video and then return when it finishes. Okay, so our load test finished. And these are the results. Checks 100%. Response time was less than 500 milliseconds. Data received 3.3 megabytes. Data sent 106. Blocked. Spent how much time was connecting, the duration of the HTTP request, 0% failed. That would be a key one to pay attention to, right? And then I guess you'd want to look at how much time, shortest time to longest time, whether the longest time is acceptable for your needs. And then you could look into the details of what makes up the time. Anyway, I hope that's useful for you. As I said, there are different kinds of load testing you could do. You can get very creative with that. but at least I wanted to show you how you could work it into the GitHub workflow. That's probably the main value of this. Okay, please feel free to post any questions you have in the thing below the video, and I will see you next time. Thanks.